Okay, so thank you. Welcome everyone to today's Ask the Expert session. I'm Stefan Chakow. I'm going to be sort of your MC here, and I'm joined by a number of folks on the team. We've got Gaurav, Shamir, and Tulika all with us who work across different parts of the app service portfolio and will be available to answer questions and, engage in the chat today. So, just to kick things off, real quick, we wanted to go through a few slides, quick, brief demo about sort of the state of the union of what things look like when you're a web app developer and you're running on, for example, Azure App Service, and you're thinking about how would you integrate AI style workloads to sort of bring a degree of intelligence to your web app. So on this screen, I've just got a URL up at the top with a link to a GitHub repo. And again, I've got these links all in a slide here in a few minutes as well that folks can take a screenshot of. But this is the general architecture of sort of one of the very common demos that's out there. It's linked to from the Azure OpenAI documentation that's up on the Learn site. And it uses I believe, a Node.js web app running on App Service, which then interacts with OpenAI and the LLMs and a few other services over in Cognitive Search to provide a chat-like experience. The main thing is it's all doing it in the context of just sort of a straightforward web app. And then what I'm going to show you here in a minute is a little bit of a more complex app. Again, it's sort of a demo app that shows a variety of different ways of bringing in textual LLM style AI functionality into a web app. And, a couple of takeaways here is the web app is just one part of a much broader set of software and services that are running to bring everything together for the customer. Um, Ultimately, the web app is running the presentation tier in this demo app as well as others. And then there's always a back end that's sort of used to proxy the interactions and requests to a variety of AI resources. What's interesting about this demo app is it's using the Azure bot service as sort of the back end to interface to everything from OpenAI to cognitive search services to Bing search to Azure SQL. So let's just take a real quick look. This is the app running in my browser. The front end is a straightforward Python-based front end, and it's got a search and a sort of a chat option. Now, earlier I went out and I tried out the search option, put in this text here. Again, it's a little bit of a low volume app. It's throttled, so that's why I ran this ahead of time. But you can see I said, hey, go give me some article references. It spat back a variety of articles. The interesting thing here is in the back end, the folks who built this demo basically used OpenAI to generate vector embeddings and then stored those embeddings as an index into Azure Cognitive Search. And subsequently, when you type in queries like this, it's using those pre-cached embeddings to then run a search against the underlying index of documents. Another variation they have here in this demo app is they have 5 different ways of interacting with different search functionality. So, for me, just as like a regular developer, Bing search, pretty useful, right? It just gives me an API. I don't have to worry about the vagaries of maintaining anything underneath the hood in terms of models. But again, in this demo app in the repo, they also have it hooked into various implementations of LLMs and OpenAI. And you can see again a little bit earlier, right, 20 minutes ago, I put in a query and said, hey, why don't you answer this question, but using the chat GPT functionality that's built into the app. And so, of course, I get the nice summary set of results. The interesting thing here is I'm getting a summary set of results that's generated in combination off of the LLM, as well as the fact that this demo app is built in a way so that it's trained off of a subset of data. So it's not just like a random set of information coming back from the internet. So it gives you the general idea there of sort of how this stuff is put together. To simplify it, there's really 2 approaches we see folks today when they're running web apps on app service and saying, I want to bring some AI functionality to it. The simplest approach is you just take your favorite front end and all of these demo apps that are out there in GitHub, they're either using Node React or some variation of Python for their front ends. And then you're just using the available APIs to interact with Azure OpenAI, right? And if you set up an OpenAI model, for example, using Azure AI Studio in the portal, it's as simple as you just get a URL, you get an API key, and then you can start sending it JSON documents that basically represent your queries, and you get back responses. And then you can sort of enlighten that approach by, for example, adding some kind of cache look aside pattern. Again, this is not meant to be the exhaustive way of every way you can do it, but showing two common ones, cognitive search, and then also sort of more of a roll your own using vector search support in Azure Cache for Redis. The sort of the challenge with this approach is, of course, your web front end, even if it's running a companion backend like a Python Flask API endpoint, it can get real complicated real fast because you have a bunch of functionality now sort of glommed into your web app code base. So over time, certainly for longer term investments, this diagram is probably unsurprisingly suggesting take all of that AI functionality and be able to hide it behind a broader service infrastructure that's specifically built to deal with sort of the churn and the variations in AI implementations. And again, this is just showing one approach. It's certainly not the only approach. It's not the single definitive approach, but it should be familiar to a number of folks, which is in essence, your web app interacts with AI resources as an API. We have a great product with Azure API management that you can use as a front door to those AIs so that your web developers are, a level removed from all the implementation details. And then that way, underneath the hood, when you're doing things like switching between different chat GPT models or different caching implementations, you have the freedom to do that without churning and needing to make code changes upstream in your web app. And the final point here on the diagram that I'm pointing out is something to think about is putting Azure API management in front of Azure OpenAI itself. Like I said a minute ago, OpenAI is going to give you a URL endpoint to go query. It looks and feels and operates like an API. Being able to put that behind a gatekeeper like API management is a great architectural approach because then again, you can do things like throttle the request rate to that precious AI resource so that your web front ends don't overrun the AI backend. And you can also do things like manage keys, manage versions over time. So for example, if you're switching between different versions of Chat GPT, you can hide those implementation details behind a level of indirection. So I'll just park on this slide here for a couple of seconds. It's got just a couple of links from what I touched on. A lot of them are links off to various sample repos showing how to use OpenAI, ChatGPT, cognitive search, you name it. And then also I have a few links to more recent articles talking specifically about, for example, how you can use API management with Azure OpenAI, and similarly how to use Azure Cache for Redis as a vector search database to help optimize your queries. So at this point, let's switch back to the general chat and see what kind of Q&A we've got going. Okay, so let's see. I think we have a few questions that we've got there for moderators that we can pick. Let's see here. Okay, so there's a first one, just looking through some of the items saying, hey, you know, how easy is it to, for example, migrate a .NET or a Java app to app service and then sort of plug in AI capabilities? So I'll tell you what, I got a couple of, again, our product experts here. Gaurav, I was going to say, you know the ins and outs of migration. Can you speak to that for a little bit?
Oh, yeah, absolutely. So, when it comes to migrating your on-premises, as App Services engineering team, we have been making significant investments in past couple of years. And what we have done is we have actually built a host of tools using which you can easily migrate your on-prem web applications to Azure App Service. And again, when I say multiple tools, they are all doing the same thing behind the scene. But what we have done is we have specifically targeted them for a scope. So if you're looking at migrating multiple different servers and hundreds of web application at the same time, you go ahead and use the Azure Migrate integrated experience, which lets you discover, assess, and migrate .NET and Java web applications in bulk. Similarly, we also have PowerShell based migration experience. So again, if you are looking at migrating a single IS web server at a time, that's where you use PowerShell. Or if you're even looking at migrating just a single web application, again, we have App Services Migration Assistant. Now, most of these tools look at the configurations of your web application. What we have also been working on is how to get deeper into the source code analysis, so that we can let you know that what are the kind of changes you should be making so that you are more successful at your migration journey. So for the Java source code analysis tool, it's already there in preview. And let me tell you, we are working for a similar tool when it comes to .NET as well. So yeah, I mean, we have a lot of investments going in from an engineering perspective when it comes to app service migration tooling. And remember, once your app is migrated to app service web app, I mean, we can use all the goodness that Stephen, you just demoed, I mean, in terms of using all the latest and greatest AI capabilities and other advanced capabilities that app services has to offer as a platform. So yeah, it's super easy. That's my quick
Cool.
answer.
Yeah, cool. Thank you, Gaurav. And then also, just to sort of round up there, like Gaurav was mentioning, on one hand, it's not, when you want to enhance a web app with some kind of AI functionality, on one hand, it's not, you don't, press a metaphorical button and suddenly, ta-da, the app suddenly has AI functionality. But the recurring theme here is, think of it as just it's an API endpoint. And just like you would call other APIs that probably you've built as developers for business logic, domain specific information that you're reading and writing and presenting in the context of a web app, what's very cool and powerful about the AI functionality today is ultimately having it boiled down to, it's in some ways just another API endpoint. And so just how you think about how you would call APIs you're familiar with today, now you're going to be calling APIs that are able to have more of a question and answer approach, more of a textual search functionality. And so, again, just narrowing the lens to the point of view of the web app developer, you follow the same playbook, right? Secure your API endpoints, try to run them in a virtual network, don't open them to the outside world. Be aware of the fact that it's very possible your web app might have more load running on it than your AI backend can handle. So, thinking about throttling patterns, things like that. So it's more just think about the common sense approaches for how would you consume an important API endpoint. In this case, it just happens to be providing AI functionality to your application. Okay, cool. Well, I'll tell you what, let's go take a look at some other questions. So let me see. How is automatic scaling different from Autoscale for app service web apps? Okay. Speak of the devil again. It is a bit different. I'm going to defer back to Gaurav, who also happens to be our feature owner. And you probably, if you were here attending virtually or in person, might have seen him talking about this feature not too long ago at Build. So yeah, Gaurav, give us the state of the union on that.
Yeah. So again, when it comes to scaling, I should say that is one of the most important pillar or one of the most important benefit that App Services as a platform has to offer for your web applications. And we always had the manual approach towards scaling, where you could just drag a slider and get more instances as and when you need. We also had the rule based scaling. Now when we say rule based scaling, it's more about you go ahead and either choose a metric, let's say data in, data out, or what kind of CPU or a memory usage your web application is having, And based on that, you go ahead and say that, yes, I want an extra instance, or I want a couple of extra instances for my app services, web app. I mean, so yeah, that's what I meant by rule-based scaling. And it also gave you an option of having a timer based or a schedule based scaling. Basically, I could say that probably during the weekdays, I want my web application to be on X number of instances, whereas over the weekend, I might want to have it like X minus 2 or X minus 5 kind of app service plan. Having said that, we also heard a lot of feedback from folks that have been, all our customers have been using app services, that they also wanted a mechanism which was more like intuitive and more like a cruise mode of scaling. So something like, uh, they expected us to take care of scaling behind the scene, whereas the customers just tell us what's the maximum scale or the maximum bound for the app service plan, and maybe can they set some kind of a min and max boundaries for every individual web application within the web app. So that is precisely what automatic scaling does. So how it differs from Autoscale is, as I said, Autoscale is all about you configuring the metric and you as a customer configuring maybe the schedule. When it comes to automatic scaling, we have automated, or we have taken care of a majority of these complexities. What we do behind the scene is, you just tell us that, probably, I mean, for my app service web app, or for my app service plan, which maybe has more than one web app, I want my app service plan to scale up to 30 instances. But for an app service A and app service B, probably I can let them scale all the way up to 30, or I can even limit them to scale up to 10, so that I don't overwhelm any of the backends that they are connected to. So yeah, these are all different flexibilities that you have, but behind the scene, we have taken care of all the complexities of metrics. So the idea here is, based on your entire HTTP request traffic, we do the magic behind the scene.
Cool. No, cool, great. Yeah, thanks for that run through, Gaurav. Also, I know Gaurav and company, they've been working pretty busily behind the scenes to get a lot of the feedback that we've gotten from all of you over the last few months plugged back into the product. Stay tuned. We'll see what we have to say about that in a few short weeks here at Ignite, which, again, shameless plug. Ignite's coming up in the not too distant future here. But yeah, the automatic scaling feature, it's definitely on the path to moving to a GA here on the service. We're really excited about it because, in large part, it's meant to sort of take some of the mystery and heavy lifting off of your hands and say, hey, why not have the platform figure out how to do the scaling on your behalf. Um, Also, again, just given the theme of this Ask the Experts about intelligent apps, I know for folks, one of the things that they'll worry about when they're scaling their web apps is, these days, the reality is you can scale out your web apps faster and with more hardware than you can frequently get your back ends to scale out and keep up with what you're doing in your web tier. So again, regardless of whether or not you're talking about an AI backend or a SQL database backend or your own APIs, that is something, right, from an architectural pattern perspective, to always keep in mind, which is, be aware in the sort of the different layers of your application architecture. It's very possible, very likely, your web app is going to be able to run away faster than some of your backends can handle. So, reprising what I mentioned there in the slides a few minutes ago, whether it's a pattern you build or using something like API management to help throttle down the rate at which you're passing requests to those bottleneck resources, especially for larger, more complex app architectures, that's definitely something to think about. That's definitely a good architectural practice. So, okay, cool. Good discussion on that. Let's see. What else do we have kicking around here? So I see, how does Azure App Service make use of AI functionality today? Yes, a nice broad-based question. Well, I'll tell you what. First, let's, Shamir. I know in the diagnose, solve, supportability area, there's definitely been some exciting things that have been going on in terms of AI functionality. Can you sort of speak to that?
Sure thing. Thank you. Yeah, so in the diagnose and solve blade and in diagnostics in general, we are using LLM and integrating co-pilots. We will be having a demo during Ignite timeframe where we'll be able to talk about how we're going to use conversational mode of communication with the system to be able to give you rich diagnostics and help you get to resolving the issue by just asking a question to the system, right? So that's one thing we are doing. And then we are baking in rich AI experiences to summarize what our diagnostic tools do. So today you get a bunch of insights, you get a bunch of verbatims or graphs and charts to help you understand the problem. But we're going to simplify that by just, making use of AI and tell you what the problem is and what the steps are to resolve the problem. So those are some of the things that we're going to do, and some of this will be showcased in Ignite.
Cool, cool. That's this is one of these things where if you go into the Azure portal and you look at, for example, the overview blade when you're looking at a web app running on app service, right up there towards the top, there's that entry diagnose and solve. And I can't evangelize it or cheerlead it enough. The team that Shamir works with has done a heck of a lot of work over the past years to try to distill down a lot of the wisdom, best practices, troubleshooting knowledge into that experience. And again, with the introduction not only of the LLMs, but also just AI all up, right? The machine learning algorithms that can run behind the scenes. Shamir and team have been doing a lot of work, both in terms of what we call the detectors, which is what in large part processes and drives a lot of the data that you see there in the graphs and the guidance that comes up there, as well as, again, more recently, right, being able to do the LLM integration so that you can, get to a point. It might not be as simple as tell me what's wrong, because that's a super broad question, but get to something where you can have a better idea of, like, okay, can you help me drill into what's going on with, like, why am I having slow web application startup? And so, again, it's one of those exciting things where it's a narrow enough problem space, right? It's got those guardrails and boundaries around it, so that you don't have to worry about AI models wandering off into the weeds. And we, underneath the hood, have rich diagnostics, metrics, logs, and you work together over time to put those together, so that, again, a shameless plug there, in a few weeks, excited to see what's new, what's coming up, and again, the teasers for what's even coming beyond that. Um, Also, just because, again, it's an interesting question. It's a broad based question. A couple of other things, just when you think about what goes on with AI and app service all up as a platform. To give you an idea, if you use the private cluster app service environment feature that's on app service today, the newer variation of it, we are already using underneath the hood, in conjunction with our partners in Azure, ML algorithms to help size the underlying buffers that back the scaling functionality in app service environment v3. And that's something where, again, a few years ago, that would have been a pipe dream. But being able to sort of plug in the ML functionality and the data science functionality that the folks have at a very low level in the fabric of what makes Azure tick, and bring that together with the scaling functionality that you see there today with app service environments, that's a really powerful thing to help improve scaling performance all up for the platform. And again, it's one of those things where we're focused today a little bit more on the ACE, the app service environment side of the universe, for that ML application. But again, as time passes and we get things smoothed out, you can expect to see that functionality also come over to the public variation of app service, and be able to start applying smarter scaling sort of underneath the hood, so that you get more consistent, better scaling performance from your perspective. In a similar vein, again, active area automatic scaling that Gaurav was just talking about a few minutes ago, right? That's something where I think today it's not quite yet ML driven, but that's something where behind the scenes, we're the ones who implement the sort of the statistical algorithms for that. So that's another great area where we're able to add that capability to the platform. And then the one last thing is switching it around again from a customer perspective. I don't know that we'll necessarily be able to have a specific session on it here at Ignite, but the .NET folks, .NET developers, they rolled out not too long ago an AI-driven enhancement to the profiler that's available for .NET apps. I think it's .NET Core in conjunction with Application Insights. And if you take a look out there, it's out. They have an article on Tech Community about using the .NET AI functionality with the profiler there, the info that comes out of App Insights. What's cool about it is for all of us as app service customers, right? If you create a .NET app these days, we just enable App Insights for you. And then you can go in there and very easily sort of turn on .NET profiling, as well as sort of how intensive you know collect those profiles, since you don't necessarily want them being collected on every single request. But since you've already got like all the heavy lifting done and App Insights is already integrated with your .NET apps, the rest of what's going on is over in the .NET and App Insights side of the house. So if you take a look at that Tech Community article, you can very quickly start enabling it and getting the ability of the ML algorithms they use to look at your live code that's running in production and give you insights on like, this appears to be, CPU or memory negative allocations or performance issues that you're having, and really get you those deeper insights that the reality is in days of old, you'd have to sit there and drag out a debugger and run it on a machine and try to actually spelunk what's going on. So just getting to that level of like live or nearly live supportability and diagnosability so that all of us can more quickly see what's going wrong with different parts of our app. That's frankly the thing I find that's most exciting, because I think, again, as the months and the years pass, that is going to make for a much more productive experience running on our services. So, okay, cool, good on that. Let's see, what else have we got? Oh, yes, my favorite one. Does app service support GPUs? Yes. And I see that question constantly all over the place. Tulika, I know we haven't given you a chance to talk yet. Tell us, do we support GPUs?
Well, not yet, but we are working towards having some kind of GPU support for app services. We do want to enable you to how to create intelligent apps or AI-based apps. We want to make the experience as simple as possible for you. So we are looking at having GPU support, but it's not there right now.
Yeah, it's one of these things where behind the scenes we have all the bits and pieces that we could put it together. But somewhat jokingly and somewhat seriously, as you can imagine, there's a line that's like 20 miles long, who all want to get to some very, very expensive hardware, and so that's why certainly for at least the near term, ultimately the way all of us will interact with that functionality is again through something like an OpenAI or an Azure Cognitive Search endpoint. But definitely it's something where I think over time, in all seriousness, as the silicon matures to the point that it's, at least for some workloads, specifically inferencing, that you don't always need the highest end, most exotic silicon, definitely as sort of all of us move to a point where that becomes a lot more viable and a lot more realistic, I do foresee that we'll be able to get at least functionality that speeds up inferencing and get that over time as something that's available on App Service.
In the meantime, we have the latest versions of Python running in case you want to play with some, machine learning, AI
Yep.
apps.
Exactly.
Come over
For
and
like
try it out.
personal development, learning, experimentation. I mean, absolutely, right? So, okay, I see we are slowly but surely running out of time. So very quickly, definitely big thanks, Tulika, Gaurav, Shamir, and the folks also working behind the scenes to come here, present, and get everything running smoothly. Thank you, everyone who's been here live attending and asking us questions, and also for folks who watch this afterwards. Thank you for coming in, watching, learning, and best wishes. I think it's a great time to be a developer. It's exciting to see what's available on AI and LLMs, and yeah, frankly, the sky's the limit here.
Thank you everyone for joining.